Hello and welcome. Today, we are diving deep into the financial engine of the cloud, the consumption-based model. We will explore how shifting from owning hardware to renting services transforms IT spending from a capital burden to a flexible operational advantage. Let's begin by defining the consumption-based model. At its core, this model means you are renting computing resources like servers, storage, and databases from a cloud provider's data center instead of maintaining your own. Think of it like a utility bill. You pay for the water or electricity you use, and nothing more. If you don't use any IT resources in a given month, you don't pay for them. This approach eliminates the need for purchasing and managing costly infrastructure that might sit idle, allowing you to treat computing resources as a flexible service rather than a static asset. This flowchart visualizes the cycle. It starts with the user requesting resources from the cloud provider. The provider instantly provisions items like virtual machines, storage, or databases. Crucially, all these resources feed into a usage meter. This meter tracks consumption in real time, resulting in a bill where the user pays strictly for that usage. This direct link between provisioned resources and billing is the heart of the model. To understand the impact of the cloud, we must contrast capital expenditure, or CapEx, with operational expenditure, or OpEx. Traditional IT relies on CapEx, requiring significant upfront investment in physical buildings, cooling systems, and servers before you even deploy an application. The consumption-based model shifts this to OpEx. This means you are spending money on services over time, with no upfront costs. This shift allows for greater financial agility, as you avoid the risk of overestimating your needs and buying hardware that ends up underutilized. You simply pay as you go. Here we compare the two financial models. On the left, the CapEx model, associated with traditional IT, involves upfront investment, static capacity, and depreciation. On the right, the OpEx model, associated with cloud computing, is defined by having no upfront costs and offering flexible capacity. This visual distinction highlights how the cloud transforms fixed physical assets into variable service consumption. A major benefit of the consumption model is the relationship between scalability and cost. In a traditional data center, you must guess your future needs. If you underestimate, your performance suffers, but if you overestimate, you waste money on idle hardware. In the cloud, you can scale resources up or down rapidly. If you need more virtual machines for a busy week, you add them. When demand drops, you remove them and stop paying immediately. This elasticity ensures you are running your infrastructure efficiently, matching your spend directly to your business needs. Different services offer different efficiencies. For example, function as a service, FaaS, charges only when code is actually executing, maximizing cost effectiveness. This diagram demonstrates the elasticity of the cloud. When a traffic spike occurs, the autoscale logic triggers. If demand rises, it provisions new resources, leading to a temporary cost increase. Crucially, when demand falls, it deprovisions resources, leading to an immediate cost decrease. This dynamic adjustment prevents the waste inherent in static infrastructure. While consumption implies paying for what you use, there are different ways to pay. The standard model is pay-as-you-go, offering maximum flexibility with no commitment. However, if you have predictable workloads, you can optimize costs using reservations. By committing to a 1-year or 3-year term for resources like VMs or SQL databases, you can save up to 72% compared to pay-as-you-go prices. Similarly, savings plans allow you to commit to a specific hourly spend for greater flexibility. These options allow you to mix the flexibility of OpEx with the lower rates of long-term planning. This chart helps visualize the trade-offs. Pay-as-you-go sits in the bottom right, high flexibility but lower savings. Reservations are in the top left, high savings but lower flexibility because you commit to specific resources. Savings plans offer a middle ground in the top right. This helps you decide which consumption model fits your specific workload needs. Because costs are variable, management tools are essential. The pricing calculator allows you to configure resources and estimate their costs before you deploy anything. Once deployed, Microsoft Cost Management provides visibility into your spending, allowing you to track trends and forecast future costs. You can set budgets to alert you when your spending reaches a certain threshold, preventing billing surprises. Additionally, using tags allows you to categorize resources such as by department or project to accurately allocate costs and hold teams accountable. This sequence diagram outlines the cost management workflow. First, the user consults the pricing calculator to get an estimate. Next, they deploy resources to Azure. Azure then continuously reports usage data to the cost management tool. Finally, Cost management sends alerts and budget reports back to the user. Closing the loop on financial governance, it is important to know what specifically drives your bill in a consumption model. First, the resource type matters. For example, storage might be billed by capacity, while compute is billed by CPU hours. Second, settings play a huge role. Selecting geo-redundant storage, GRS, costs more than locally redundant storage, LRS. Third, the Azure region you deploy to affects the price due to varying land and power costs globally. Finally, be aware of network traffic. While data moving into the cloud is often free, data moving out egress typically incurs a charge. This mind map breaks down the components of total cost. We see resource configuration branching into size and tier. Region highlights that location matters. Data transfer specifically flags outbound costs. Maintenance includes often overlooked items like IP addresses and licensing. All these factors aggregate to form your final consumption bill. To summarize, the consumption-based model fundamentally changes IT economics. By eliminating upfront investments, it shifts spending to an operational expense model, OpEx, reducing financial risk. It drives operational efficiency by allowing you to pay only for the resources you actually use and scale them instantly. However, this requires continuous optimization using tools like Azure Advisor and cost management to ensure you aren't paying for waste. Ultimately, this model frees you to focus capital and effort on solving business challenges rather than managing physical infrastructure. We conclude with the life cycle of consumption. We start by assessing needs, then provision resources. The core loop involves consuming services and monitoring costs. Based on monitoring, we enter the optimized state, where we either adjust usage and loop back to consumption, or decommission resources entirely to stop costs. This cycle ensures continuous value.